Understanding humankind's vehicle for advancement, engineering. Important questions to explore. What is engineering? When did it begin, and how has it developed over time? What does an engineer do? How many engineering specialties are there? How much education does it take to become an engineer? What's the best way to prepare to become an engineer? Is there a difference between engineering and technology? How does engineering utilize technology? Important questions to answer. Do I want to pursue engineering as a field of study? What specific engineering specialty should I choose? Why should I appreciate the need society has for engineers? Can I explain how engineering began and developed? Can I list possible topics that engineers will be studying in the future? How do we define it? The field has been defined by the Engineers Council for Professional Development in the United States as the creative application of scientific principles to design or develop structures, machines, apparatus, or manufacturing processes, or works utilizing them singly or in combination, or to construct or operate the same with full cognizance of their design, or to forecast their behavior under specific operating conditions, all as respects an intended function, economics of operation, and safety to life and property.
What is engineering? Let's take a moment to think about your morning. The alarm on your phone goes off at 7:03. You drag yourself to the shower and blast yourself with perfectly warm water in an attempt to wake up. You smear your toothbrush with too much toothpaste and scrub yourself into a foamy mess of minty freshness. You're running late, so you skate downtown, weaving through the commuters, dart across the road, barely making the lights, and jump on the train just before the doors beep shut. There's a couple of stops to go, so you pull out your phone and play a few games of Angry Birds. Alarms, trains, traffic lights, video games, toothpaste, all these things were made possible by engineers. But what prompts an engineer to improve our world? Well, they solve problems. Problems are an engineer's inspiration, and maths and science are the creative tools they use to solve them. Problems like making your alarm go off at the right time, or making sure your toothpaste has just the right balance of chemicals to give you that perfect smile, or even making a game so addictive it's almost impossible to put down, if that really is a problem. Now let's head over to the airport and jump on an aeroplane. Aeroplanes. They're so easy to take for granted. But don't forget, you can fly! Before aeroplanes, flying was quite a bit more challenging. Every bit of your plane has been touched by engineers. A mechanical engineer designed the engine. A mechatronics engineer devised the controls. The fuel? Extracted by mining engineers and refined by chemical engineers. The navigation systems? Electrical and software engineers created those. Yep, a whole team of engineers. Now we've landed in Dubai, home of the Burj Khalifa. It's the world's tallest building at 829.8 metres high. It's also in one of the world's hottest environments, reaching up to 50 degrees in summer. One of the difficulties of building the Burj was trying to figure out how to set 45,000 cubic metres of reinforced concrete in such extreme weather. The solution? A clever method of pumping iced liquid concrete into the 55,000-ton steel frame during the night. The result? A building that's vertically over 800 metres high, rather than horizontally all over the ground. Now let's jump into our time machine and go back to Saturday. Saturday, March 1932. The Sydney Harbour Bridge is about to open. The bridge is a marvel of civil engineering, and a pretty cool place to set off some fireworks. Since 1815, people had been talking about building a bridge to connect the two sides of the harbour. The problem was that the harbour was so incredibly wide. how could a bridge span such a width and support its own weight? The solution? The Romans! Well, actually it was an idea they came up with. The arched bridge works by transferring the weight into horizontal forces and bracing them at the ends of the arch. But what about the future? What problems will engineers solve next? Will we finally have affordable solar power? Or robots that can perform life-saving surgery? Or a building that's so tall your view is of outer space? Or how about finally engineering a working hoverboard? Seriously, we've waited long enough. So what is engineering? It's solving problems. It's taking crazy, out there ideas and seeing if they're actually possible. And when they are, the idea is shared with the world to make all our lives better. So, what problems do you want to solve?
Take 5 minutes to write down your understanding of the role engineering plays in helping our society. Checkpoint 1. Where and how did it all begin? Engineering historical timeline. The first known engineer was Imhotep, the builder of the Step Pyramid at Saqqara, Egypt, probably in about 2550 BC. The Egyptians, Persians, Greeks, and Romans carried civil engineering to remarkable heights on the basis of empirical methods aided by arithmetic, geometry, and a smattering of physical science. Vitruvius's De Architectura, published in Rome in the 1st century AD, covered building materials, construction methods, hydraulics measurement, and town planning. Villard de Honcourt, the 13th century French engineer, revealed an extensive knowledge of mathematics, geometry, natural and physical science, and draftsmanship. Engineering had a similar development in Asia, with more and more sophisticated techniques of construction, hydraulics, metallurgy, which helped to create the Mongol Empire, whose cities drew the attention of Marco Polo in the 13th century. Where and how did it all begin? Continued. Civil engineering emerged in the 18th century and generated the first professional societies and schools of engineering. England and Scotland were the birthplaces of mechanical engineering, a result of the inventions of the Scottish engineer James Watts and the textile machinists during the Industrial Revolution. Alessandro Volta's original electric cell, 1800, and other works through the experience of Michael Faraday and others, culminating in 1872 in the Gramme dynamo and electric motor named after Z.T. Gramme, led to the development of electrical and electronics engineering. The electronics aspect of engineering became prominent in the late 19th century with the work of James Clerk Maxwell and Heinrich Hertz, the development of the vacuum tube by Lee de Forest in the early 20th century, and the invention of the transistor in the mid-20th century were significant milestones of electronics engineering. Chemical engineering grew out of industrial processes involving chemical reactions. The use of chemicals in manufacturing had created the need for mass production of chemicals. Stop. Take 5 minutes to write down 10 developments in the engineering field from the time of Imhotep through the mass production of chemicals for industry. Checkpoint number 2. What skills are needed to be an engineer?
My name's Bethan Murray and I've just finished my first year at Rolls-Royce doing an apprenticeship.
My name is Lara Small and I'm a team leader in manufacturing engineering. The reason why I chose engineering is because I find it an absolutely fascinating subject. You are responsible for improving and changing technology. You have to understand how things work and then figure out how you can make them better.
One of the main reasons why I got into engineering in the first place was because I was lucky enough to be sponsored to go to space camp in America, in Alabama. So after spending a week there, I decided aerospace engineering was definitely something that I wanted to look into. So my family encouraged me to have a look at Rolls-Royce because obviously they're a key player in the aerospace industry. There's so many different benefits to an apprenticeship, but obviously there's the key ones that everybody thinks about, so salary, business experience, having things like that on your CV, having companies on your CV already. But to me, more personal, it's the skills like confidence and being able to walk into a room full of managers, deliver a presentation and have kind of faith in your convictions in doing so.
A typical day for me involves getting in early and checking my emails and then having a look at which meetings I need to be in. And what that involves is getting the right engineers in the same place in order to make a decision on an engineering component. I'll then pop down to the shop floor to see how the operators are getting on and having a look at the component that is in manufacture. And as a result, seeing what I've designed come to life.
At the moment, my typical day is in PCF, which is Precision Casting Facility. So I'm overseeing the installation of a brand new kind of fully automated machine. Overall, my responsibilities are within project management at the moment, but I get the exposure to all the different engineering functions. So it's just making sure everything's running to plan, which quite often it doesn't. The key one for me is the placement that I've just finished at Aero Repair and Overhaul. So we bring in the civil large engines that you see when you go on holiday, strip them down and rebuild them. I was working in business improvement, so my kind of role was to look at the processes we do and see how we could potentially do them better.
I've been all over the world working on a variety of products and it's been fascinating. And I've also worked with a variety of people that I never thought I'd get to meet. In terms of Montreal and Vietnam and in Singapore. And as a result, it's been brilliant because I get to work on products that I can see and products that I can change and feel, which I find absolutely inspiring.
For an engineering apprenticeship, there's obviously the technical side, so you need logical reasoning, numerical reasoning, and they come naturally when you study subjects like science and maths or kind of physics subjects. But above and beyond that, you just need drive and passion.
It's important to be part of a team. Engineers never develop anything on their own, and so you need to be able to communicate effectively and share your ideas.
Well, the company are really good at giving you all the skills that you need, not only in engineering but also in the business side of things. So I've been on courses like facilitation skills, presentation skills. I've done things like financial analysis, which make you just really transferable within the company. So you're not just engineering and technical. You've got an understanding of how to get the best out of people and the best out of the resources that are available to you.
Apart from engineering skills, I've learned how to be a leader. I've been on a couple of courses that have taught me how to get the most out of a team and therefore deliver a product on time to a customer.
Get some work experience, do any extracurricular activities that they offer at school or outside of school so that you can not only have that to put on your CV, but you'll also understand yourself whether you're going to enjoy what you've applied for and what you're going into. It'll give you an understanding of how things work in the real world above and beyond kind of the education system.
Stop. Take 5 minutes to write down 10 skills a person needs to become an engineer. Include both soft skills, interpersonal, as well as hard skills, academic abilities. Checkpoint number 3. What is a typical academic career path for an engineer? There are so many engineering disciplines that, in order to answer this question, it is necessary to pick one specific career as an example. Let's take a look at what a person has to study to become a welding engineer at Ohio State University's College of Engineering. Welding Engineer, WE, Undergraduate Curriculum Overview. Students typically begin their WE career at Ohio State as a pre-major in the program. During the freshman year, students complete a common engineering curriculum of math, chemistry, physics, and English. First-year students also enroll in either the Freshman Fundamentals of Engineering program or the Honors version, which offers access to hands-on engineering labs and projects. Second-year welding engineering students continue taking pre-major courses in electrical engineering, computer programming, mechanical engineering, statistics, a hands-on welding lab, and materials science and engineering, along with university general education courses. Students wishing to apply to the major do so in the autumn by November 1st. New WE majors take survey of welding engineering and materials thermodynamics in the spring of the second year. In the third year, welding engineering major students continue with structural transformations, materials and processing lab, physical principles in welding engineering, welding processes and applications, welding engineering design, non-destructive evaluation, welding metallurgy, and various labs. A welding engineering internship is required and is usually done in the summer before a student's final year. Students receive course credit for this as a welding engineer 3189 industrial experience. The senior year finishes with additional welding metallurgy courses, a year-long senior welding design capstone project, and several technical electives of the student's choice. Engineering and technology. One of the best glimpses into the tightly interrelated functions of engineering and technology can be found on the home page of the Advances in Engineering webpage. It is obvious that there's a strong partnership between engineering and the advancing technologies we read about each and every day. Engineers must be technologically literate if they wish to take full advantage of the problem-solving capabilities technologies offer. Technical terminology. Since there are dictionaries written expressly to define engineering terms, it is safe to say that engineering has a language all of its own. Here are a few examples of welding engineering terminology: acetone, acetylene, actual throat, air acetylene, air arc cutting, alloy, alternating current, ammeter, and annealing.
My name is David Phillips. I'm an associate professor of practice here in the welding engineering program. Over the years, I worked for a variety of companies that some of them did quite a bit of work with Ohio State. I would come up here to visit and I would walk around campus and I would just feel the energy, and I just always knew if I ever had an opportunity to come back here, in particular to teach, it would be like a dream come true. What I really liked about welding engineering is that you have to take a whole variety of courses to be a welding engineer. You have to take engineering mechanics, you have to take metallurgy classes and material science classes, you have to take electrical engineering classes, you have to know about all the welding processes from lasers to electron beams, lots of things that are very different from what people think when they think of welding. They think of arc welding. You have to know design, you have to know non-destructive testing techniques like X-rays and ultrasonic inspections. One of the other really neat things about graduating with a welding engineering degree is you have a wide range of possible career paths, and by that I mean not only the types of companies and the types of industries that you work for, but the types of specific job functions. So for example, I have several friends that work in the medical field, and so they're working with things like pacemakers that go inside the body, and these are made out of exotic materials like stainless steels and titaniums. Ranging from working in the medical field, I spent 5 or 6 years of my life working with jet engines in Cincinnati, and again, exotic high temperature metals, nickel-based, what we call aluminides, and all kinds of fancy metals like metal matrix composites. A lot of people like the excitement of a high production industry such as automotive, where things are happening fast and there's lots of action. So production type jobs are very common for welding engineers. A lot of our students end up in nuclear fields working with nuclear pressure vessels and petrochemical, working in the oil and gas pipeline industry. So all kinds of industry sectors, all types of job functions are out there for you as a welding engineer. Ohio State is the only ABET accredited welding engineering program in the country. When I think of Ohio State, I think of energy and passion. And I think of a big family.
How many branches of engineering are there? There are 10 major branches of engineering: aeronautics and astronautics, biological, chemical, civil, computer science, electrical and electronic, environmental, mechanical, nuclear, and systems. Stop. Take 5 minutes to write down 10 reasons engineers need to be well-versed in the terminology associated with their specific field in order to be successful.